All right, let's jump right in. We're about to connect three things that sound like they have absolutely nothing to do with each other. The thud of an elephant's footstep, a biological law from almost a century ago, and, well, the cities we live in today. And it all kicks off with one simple number.
90. That's how many people were killed by wildlife in Kenya in 2020 alone. And this isn't some rare, isolated problem. It's what happens at the dangerous intersection of two worlds that are colliding.
You know, this conflict between humans and wildlife, it's a global thing. Over in India, elephants kill hundreds of people every single year. And beyond the human cost, which is tragic, communities are dealing with devastating damage to their crops, to their property. As our worlds overlap more and more, the need for a solution is getting really urgent.
So, here's the question. How do you know an elephant is coming before you can see it or even hear it with your own ears? Well, the answer is kind of brilliant. You listen to the ground. Researchers have developed this incredible early warning system that uses the seismic waves, the vibrations, from an elephant's footsteps to spot them from a distance.
And what's so remarkable is just how simple the hardware is. The heart of the whole thing is these three geophones. You can think of them as super high-tech microphones for the Earth. They're just sensitive enough to pick up these incredibly faint vibrations traveling through the ground, vibrations made by one of the heaviest animals on the entire planet. And this is exactly what those geophones are listening for. Each and every footstep from an elephant creates this unique seismic signature. It's like a low-frequency rumble that lasts for about 350 milliseconds with all its main energy packed between 8 and 23 hertz. Now, that's a frequency that's way too low for us to hear, but for the sensors, it's a crystal clear signal in all the noise.
Okay, so you might be wondering, how does the system know it's an elephant and not, say, a passing truck or just the wind? It uses this really elegant four-step algorithm. First, it filters out all that background noise. Then, it isolates a little window of the signal to analyze. Step 3, it checks the frequency. And finally, if the energy in that key 8 to 23 hertz range is strong enough, bam, it confirms. That's an elephant.
But look, just knowing an elephant is nearby isn't quite enough, right? You need to know which direction it's coming from, and that's why they arrange the three geophones in a triangle. By doing that, the system can measure the microscopic time delays as the vibration hits each sensor. That tiny, tiny difference is all it needs to pinpoint the exact direction of arrival. It's so smart.
And the best part, it actually works. Field tests proved the system is a successful proof of concept. It can accurately detect and track an elephant up to 40 meters away. That might not sound like a lot, but it's a critical distance that could give a community just enough time to react and get to safety.
This technology is absolutely amazing, but it kind of brings up a more fundamental question, doesn't it? What is it about an elephant that makes its footsteps a literal seismic event? To answer that, we have to zoom out from engineering and dive into some biology.
See, the entire reason this technology is even possible comes down to a universal biological principle. It's a rule that governs how animals are built and what they can do. It's all about the rules of size.
Way back in 1926, a biologist named J.B.S. Haldane argued that for any animal, size isn't just a number, it dictates everything about its design. Think about it. An insect is so small it can just get oxygen through its skin. But for a bigger animal, that's impossible. It needs a whole complex system of lungs and blood to survive. Size dictates design.
The physics behind this is something called the square-cube law. It's a simple rule, but it has profound consequences. As an animal gets bigger, its volume, and so its weight, grows by a power of 3. But the strength of its bones and muscles, that only increases by a power of 2. This fundamental imbalance is why elephants are so incredibly heavy, and it's why every single step they take lands with enough force to send a shockwave through the earth.
So we have these giant animals, governed by the laws of physics, and we have these tiny sensors that can hear them coming. But the story gets a lot more complicated when we put them both into our modern world, where the lines between wilderness and the city are just getting blurrier every day.
As animals learn to live in our cities and suburbs, the way diseases spread among them gets totally scrambled. Take raccoons. In cities, they all cluster around trash cans, right? Well, that increases contact and helps parasites spread like wildfire. Or think about freshwater runoff from our cities. It can carry pathogens that end up infecting marine animals like sea otters.
And this leads us to a really crucial ecological idea called the dilution effect. Just imagine a super diverse forest. A tick there might bite a dozen different species, and many of them can't even carry Lyme disease.
But in a fragmented suburban backyard with much lower biodiversity, that same tick is way more likely to bite the one species that is a great host, like a white-footed mouse. This actually amplifies the risk of disease for everyone.
And sometimes disease can even become a weapon. In the UK, you have the introduced gray squirrel, which does great in city parks. It carries a virus that doesn't hurt it at all, but is deadly to the native red squirrel. It's a textbook case of pathogen-mediated competition, where an invasive species can wipe out a native one not by fighting, but just by spreading a disease.
So, all of this brings us right back to where we started. We have the tech to listen, we have the ecological knowledge to understand what happens when our cities expand. The big question now is, how do we combine them to build a future where we can all coexist?
This elephant detection system is a brilliant start, for sure, but it's just the beginning. Even the researchers point out the next set of challenges. How does it handle a whole herd of elephants? Can it tell the difference between an elephant and a rhino or even a truck? Answering these questions is the next big step in making this tool even better.
And so, what started as the single vibration on the ground, it just expands into this amazing web of connections. The physics of a footstep connects directly to the biological laws of size, and that, in turn, helps us understand the ecological challenges of urbanization. It's just a powerful reminder that solving our biggest problems often means seeing the hidden connections that are all around us.
The technology exists to hear an elephant coming from 40 meters away. But as our worlds keep overlapping in more and more complex ways, the real challenge is going to be learning how to listen, not just to the ground beneath our feet, but to the subtle signals of the entire ecosystem we all share.